Hi, welcome. In this video, we're going to go over some C++ basics. Let's get started. All right, so C++ has a lot of features that are shared by many programming languages and some that are just unique to C or C++. So it has data types, integers, characters, floating points, which could be doubles or float. You have to use variables and you use names to identify them or identifiers for your variables, and it's recommended that you use in C++. I know that in Python people use just like non-descriptive names, but in C++ it's people very regularly use descriptive names. We have expressions. So expressions are not statements. Statements end in a semicolon. Expressions are used to manipulate variables. So there's different types of expressions. So you could have a Boolean expression. So example, if you say if x is greater than 10, if you remove this part right here, that is an expression. So expressions are not executable statements, or you could have a mathematical expression, x plus 10. That's a mathematical expression. In order for these to be used in your program, for example, a Boolean expression would need to be maybe in a condition. Then this would evaluate, or here you could have y equals x plus 10. You could take your mathematical expression and make it part of a statement. These are just examples, but expressions are used to manipulate values and to compare values, but you need to they're not complete without a statement or some other code around them. So we have conditions and flows of control, conditions if else, and loops for while and do while loops. We have functions. We have programmer defined types. You can define your own structs and classes. And we also have library functions. So here's a sample program. We've already been through this in the last video. This is just an example, just to remind you that all C++ programs must have a main function. It is a block of code. Blocks of code are very important in C++. They have an opening curly brace and a closing curly brace, and everything that's inside of a block of code should be indented. We are going to be nesting blocks of code within blocks of code, so it's a good idea to get used to having good style when writing your code. Indentation doesn't have the same meaning in C++ as it does in Python, but it does make code more readable. So please take a look at any of the examples provided and follow good style in your programming assignments. This is just a look at how things are stored in memory. Now there's no guarantee that everything would be stored in memory contiguously, but you have your variable. This would be your variable name that's in your C++. And then this is the value. So that would be like saying int number equals 25. So that needs to be, you need to give it the data type, the name of the variable, and in this case assign it a value. I could say int x, and in that case my operating system would find a location for x. We would not know what x's value is. It doesn't automatically get a value, but it will have a location in memory, which it will have an address of x. All right, all programs should have a header comment at the top. This is at the top of the program. It should have a description, what the program does, and it should have your name, date, etc. This is a class. In addition, there's two ways to do comments. The first way is you have a / asterisk followed by an asterisk / and then everything in between those would be comments. Be very careful, because if you put a / asterisk here and an asterisk / here, it will turn your entire source code into one big comment, and that is doesn't have any compiling code. Most IDEs that you use will be color coded, and you will be able to identify what's a comment from what's not a comment. A single line comment is just 2 /. So that would be a single line comment. All right, so we're going to talk about our primitive types. You have void types, usually used as function return types. Bool types, you can use those as data types or function return types. Anything can be a function return type, actually. Integers, those are whole numbers. Characters, those are letters. So remember that an integer 3 is not the same thing as a character 3, which is not the same thing as a double 3. So those are different. Of course, this is a numerical value 3, this is a numerical value 3, but a char has a numerical value that's not 3. It has an ASCII value, you can look that up. Floating point or doubles, and then all the other types that you will create these are the primitive types, and then you just combine them in different ways to make more complex types. So here's examples. You can declare variables. If you declare int number, again, this is how memory would look. This would be my memory map. If I declare an integer called number, my operating system will find a space the size of an integer. I do not know what is there because I didn't give it any value, but it will have an address of number. Average, I also have here average. This would be bigger because it's a double. We don't know what's there. There's nothing automatically there, but we have an address of average. You have a letter up here. Maybe letter would be stored up here. Again, it hasn't been given any value, but we have an address for our letter. And bool is the same thing, but a string is stored differently. A string is actually you must include string to use string, and it's actually stored as a character array, which will be demonstrated in the next slide a little neater. So here we have, oh, here it is. So here's a string. This is a character array. So this would be string name equals FAU, and it would be stored in memory as a character array with each, which we will get to arrays in more detail later, but strings in C++ have double quotations like this, and this string right here is made up of characters, which would be a single character F, single character A, single character U, and all strings end with a null character. So this is how strings are stored, and they are stored as character arrays. Later we will get into more details about the difference between C-style strings and character arrays. This would be, oh, I think this is already here. Yeah, we have int number, char letter. So when they get declared, they don't have values like I drew in the other slide. And then once you assign them values, then they will be given a value. Okay, so there's a thing about scope, and scope is curly braces. The slides that I skipped were just slides about naming conventions in C. So in C++, when you name your variables, you want to make sure they don't have any white space, and they must begin with either an underscore or a letter. So if I say int num, that is a valid identifier. If I say int 2num, that is not a valid identifier. Int my age, that is not a valid identifier because it needs to have no white space. Int my age 2 is a valid identifier. You can have numbers in the names of your identifiers. You just cannot have, it can't be the first character in the name. So those were the slides that I skipped. All right, so now let's talk about blocks of code and scope. So everything in C++ is set up in blocks of code, and here's an example of nesting. So I have this block of code right here, which usually you wouldn't do like this. You wouldn't declare a variable. You usually would use the nesting more for conditions or loops, but just to show you the idea of scope. If you're out here on this scope here, and then you're in here, you can access inside of these brackets, you can access both X and Y because X is here and X can be brought into these curly braces. Now here, X is outside of the curly brace and Z is outside of the curly brace, but Y is inside of these curly braces. So Z does not have access to the scope of the Y that's inside of these curly braces. We're going to use it more, the brackets are not going to be used. You're not going to, this is not good style for coding. This is just an example for understanding scope. Okay, because we're going to be doing like conditions. You're going to be like if X is greater than Y, and then you have your curly braces, and then you go inside of your curly braces, which anything that's in here is only accessible from inside of those curly braces. Another thing about C++ is when I am at this instruction right here, I only know what's above it. So right here, when I'm at this part of my program, Z is not accessible because Z hasn't even been declared yet until down here. So I can't use Z if it's been declared below. Another thing is a lot of time you'll see in loops where it has for int I equals 0, I less than 5, I plus plus, for example, and you have these curly braces. This int that gets declared in the header of a for loop is only accessible inside of the body of that for loop. So you could have in the same program another loop that says for int I blah blah blah, and this int I and this int I are unrelated to each other because they belong only to the scope of that for loop. So you just need to be very careful about understanding where you're declaring things and what is accessible. But lucky for you, you do have smart editors with your compilers and IDEs that help you to identify when issues arise. All right, void type has no value. It is the keyword void. It's usually used as a return type for a function. So when we get to functions, we will have like our function name. Here, you will have your parameter list. And you will have your return type. So one return type of a function could be void. So when we get to functions, we will be using the word void as a return type to our functions. Some of you, if you are using a Mac compiler, they like you to, in your main function, put the word void here to indicate that your main function does not take any arguments or has no parameters. So that's another place where void will be used. But in this class, we will mainly use void as a return type for functions. Bool type, it can be only true or false. So bool can only have two values, true and false. It's a data type. We will be using bool throughout this semester. Integer types. So integers are whole numbers. They have obviously no floating point values. There are signed and unsigned integers. The data type int allows negative can represent negative numbers and positive numbers. You can have unsigned integers. Unsigned integers, that's a data type that is only allows for positive numbers, and that would be used maybe if you want to iterate through an array, you want to make sure that you're not going negative. But for the most part, we will be using straight int data type in this class. You can have short integers and long integers for more, short integers to save space, long integers for larger numbers, but for the assignments we will be doing in this class, we will just need basic integers. Maybe when we get to arrays, we might be using some unsigned integers. And characters are single characters. They use the char. Use single quotation marks for the literal value of a character. So this is a character Y. The name identifier is letter. So you just use single. There are some special characters like backslashes, because in strings, if you have a string and you say hello backslash world, this is a new line. So there are some special ways if you wanted to print a backslash onto the screen because this is a special character. So backslashes and single quotation marks are also special characters. So there are special ways in which you can put some of these onto the screen if you really wanted to print them. Floating point, I recommend using double. Double is larger. So anything you wanted to do, you didn't have to worry about. It doesn't matter. You can use float or double. It's really not a big deal. I just generally use double because we're not doing any huge programs that exhaust our resources. So using double just covers if you're going to do lots of multiplication or you want to have larger precision. And so these again are examples. This is an integer, a double, a character, a string, which is a character array, and the bool type. So this would be your data type. This is saying that it's true. Bools have only two values, true or false. This would be a letter, could be the letter Y. This would be a double, could be 5.6, and a number would be 10 or an integer. And a string here is a character array, like F, A, U, null character. All right, so some things about typecasting. So when you are dealing with your data in C++, you declare your data. When you declare your data, like your integers, your doubles, your characters, you allocate memory. So you are actually declaring and allocate memory. It is not automatic. Go back and watch the last module. You have to decide what type of data you want in your program, decide how much you need of it, and declare it in your program. And then the memory gets allocated. There are ways to do dynamic memory allocation, but still, as part of the language, it's not automatically all done for you. So it's very poor style to assign one data type to another type. So all you need to do is you can typecast. So if I have integers and I have doubles and I want to change my I want to do some math and temporarily change my integers to doubles or temporarily change my doubles to integers. It's really a big deal if you change a double to an integer because they're not even the same size. You can do typecasting. So here I could take this math that is done right here, dividing my total by my number of winners, which this is an integer and this is an integer, and then I just say I want to typecast this to a double before assigning it to the double. Now this is going to solve a lot of problems because integer math, for example, if I have 11 and I divide 11 by 6, integer math is going to give me a 1. The result of integer math when 11 is divided by 6 is 1. And it doesn't round, like there's no rounding. It just says, integer math just says how many times does 6 go into 11? And 6 goes into 11 one time. It's not 1 point something, and even if it was 1.9, it's not going to be 2, it's going to be a 1. So here, if you don't cast, so here you're not actually you're actually casting this to a double so that you will do double math. Because if you do the math first and then cast it, what it will do is it will give you a 1, say, and then when you cast it, it will turn it to 1.0000 and then assign it. So you don't want to do that, but if your math in C++, if one of your operands of your math is of data type double, it will do double math. So that's one way to cast your integer to a double. Another way is to just put the word double in front of it, and this will do the same thing. All right, this word const. Const is used to prevent things from being modified inside of functions. We will be passing arrays, which are passed by pointer or reference, and we will be doing reference parameters. So many times you do not want things to be modified. Also, you can do constant global variables. These are global constants. They're not global variables, which means that I have this word max tires, which has this value 3. And since it's a constant, it's not a variable. So you're not going to put variables at the top of your program because we want to learn how to use functions properly, and we want to learn how to break up our program into different subprograms and into different files. So global variables have no purpose when you're doing those things. But sometimes you might want to have global constants or declare constants inside the scope of your program. You could also put a constant in here. A constant just ensures that whatever you declare to be a constant will not be modified during execution. All right, cout and cin. Cout is for writing to the screen. Cin is for reading from the keyboard. So you use these. They are part of IOStream. So you need to pound include IOStream, and you need to use the standard namespace. So you want to make sure at the top of your program you pound include IOStream, and you put using namespace std. All right, so cout, we've already been over this, but 2 ways to move to the next line. Inside of your string, you can put the \n, or you can put a ENDL anytime for end line. That will move it to the next line, but it does not go inside of a string. If you want to print for 2 decimal places, there are IO manip. There are different things that can be used. But if you just want to keep it with the IO stream, this is just telling, these are the set of instructions. If you put those inside or above anywhere you're printing onto the screen, you can say how many decimal places you want to print onto the screen, because automatically it's not going to print just 2 decimal places. Like if you wanted to print money, you want to print money at 2 decimal places. All right, so here is an example. This is the insertion operator. Cout is called the insertion operator. Cin is called the extraction operator. It is not recommended to get 2 inputs. Sometimes, the way that people input into the keyboard, the way things are read from the keyboard, the way white space, if you looked at assignment 0, where we are dealing with strings, I told you guys not to put white space in the strings because the way white space is dealt with sometimes causes little issues. And the return is a white space. So enumeration types, these are values that basically you give words for data, and it makes code more reader friendly. So you can declare, so these are constants. This is enumeration types. Now here we are declaring words to have different values. So you're saying anywhere it's in my program, I can use this word Jan length and it will be 31, October length it will be 31, November length will be 30. So this is just a way of defining list of constants, and use words that make your code more things that you might reuse in your program. So you want to make it available, and it makes your code more readable, like humanly readable. All right, so if you do not specify, so in the first one for the month length, we are specifying the value for each one of our names here. So, but here if we don't specify, so if we want January to be 1, you need to put a no month here first, because if you don't specify, it's going to start with 0. So here's just some examples of this being used. So we have this word summer months. So this word summer months will be replaced with 3. So that's all it does, is anywhere in my, it's like a constant, it's like a word for your for a value. And what makes it nice is, like, if you were going to be using summer months and then you're using it 20 times in your program, and then you decide to go to a different place in the country that has 6 summer months, just saying, and summer months is listed 20 times in your program or 200 times in your program, you wouldn't have to change it everywhere in your program. You'd only have to change it once at the top, and then it would be replaced everywhere. Here's an example of using June, and then June would be replaced by the number here, 0, 1, 2, 3, 4, 5, 6, and then June length will be replaced with 30. So this is just a feature that can be used, enumeration types. You certainly aren't required to use them. I don't even put them in assignments. They're just some of the features and basics of C++ programming and C programming that allows you to make your code more readable. All right, so we have operators and operands and expressions. And you can overload. If you take a look at assignment 0, we are overloading 2 operators. We're overloading, I believe, the plus operator, and there's an overload for the less than operator. We're using friend functions to do that. We are going to learn about that. Obviously, that's not something you do in the first week of class. And this is overview saying some of the things that can be done with the language. And we have fundamental expressions, variable names, and literals. So variable names would be like int number. That's a literal is a literal number 10. So that's all that means when you say literals. You operate, so you have unary operators. We address of, value at, you can these are just examples of some of the unary operators. There are binary operators. Binary operators would be used to compare things. So if I wanted to say x equals 10, you don't say x equals 10, that's assignment. You say to x equals 10, that would be comparison. This would evaluate to a Boolean if it's true or false, and most likely would be in some kind of an expression, like an if condition to test if x is equal to 10. Math operators, binary, addition, subtraction, multiplication, etc. Ternary operators, so these can be used in C++. The way that you read this is you say, if x is true, then you're going to return the value of y, and if x is not true, you're going to return the value of z. Arithmetic operators, addition, subtraction, multiplication, division, and remainder. This is a remainder. So if I said x mod y equals r, so this is going to do integer division and return what is left over. So if I said q equals x divided by y, and they were integers, and I have int x equals 11 and y equals 6. So 11 divided by 6, this result would be 1 if it was integer division. Obviously, non-integer division is regular division, would have floating point, but this is for integer division. And the remainder would say how many times 6 goes into 11, and what's left over would be a 5. So the remainder would be a 5. That's how that works. If you want to relate things, logical and relational operators, you can not something. True make it false, false make it true. Logical and, logical ors. We're going to get in the next module, we'll get in more detail about how these are used. This is just, again, overview. If you want to, so logical and, in order for a logical and to be true, X must be true and Y must be true, and then it is true. If either X is false or Y is false, or they're both false, then it's going to be false. A logical or, if X is true or Y is true, or they're both true, then it's going to evaluate to true. Equal, if X is equal to Y, remember to use equals equals, then that will evaluate to true. If X does not equal Y, that would evaluate to true. If X is less than Y, that would be true. If X is greater than Y, less than or equal to, and greater than or equal to. Okay, now we want to talk a little bit about math in C. Math in C, C++. Obviously, you have to write out mathematical expressions. The asterisk is multiplication, so b squared would be b times b. 4 times a times c would be 4 times a times c. This would be a mathematical expression. This would calculate properly because there's an order of precedence where multiplication is before subtraction, but if you wanted to make sure, you could always add parentheses. This mathematical expression is just an expression. It doesn't do anything without being part of some kind of expression. Usually it would be an assignment statement. You could assign this to the result. So keep in mind, this is just how to write out expressions. Use parentheses when in doubt. So obviously here you need to have parentheses because if you tried to say A plus B divided by C minus D, it would divide first, then add, then subtract, and that's not going to give you the same result as this. Okay, assignment operators. So assignment goes to the left-hand side. So here we have what would happen here if you declared A. You can just do int A, int B, int C equals 10. That's what you're doing right here. So if you are doing that, A does not have an automatic value, B does not have an automatic value, and C does not have an automatic value. You can declare variables and not assign them values, but they need to somehow get a value before you do anything, like before you make a calculation or try to print it onto the screen or use the value of the variable. It needs to have a value first. This would assign all of them the value 10. You can assign this way. This would take whatever value B has, add 100 to it, and then assign it back to A. So it's not going to change what B is. It's just going to take whatever value B has, add 100 to it, and assign it back to A. This is going to assign all A, B, and C to 20. So if this was your main function, like this, at the end, if you were to print them out, all A, B, and C, no matter what you did before, would now have the value of 20 each because it's going to, that's the last thing that happened. If you were to print it here, then A would have the value 110, B would have the value 10, and C would have the value 10. Okay, shortcut notation. You can write it out. I can take count, add 2 to it, and assign it back to count. And this is the same thing as saying count plus equals 2. So this is very popular to use this shortcut notation. Is it in my class? It's not required. I don't care if you use it or not, but it is it is available if you want to use that. You can do it with multiplication, division, remainder, etc. This is kind of a big deal because there's plus plus count and count plus plus. So what count plus plus does, or plus plus count, they both are going to take count and add 1 to it and assign it back to count. You can do it with minus minus as well. They're both going to do the same thing. The thing is where this is placed in your program, the order in which it happens. So here's an example right here. This is going to test and then add, where this is going to add and then test. So this is going to have an impact on how many times the loop will run, because if count is 0, in this case, it's going to change count to, count will be 0, so it's going to compare 0 to 5 and then add 1 to it. Here, it's going to add 1 to it first before it tests. So in this case down here, the loop is going to go 1 less time. And in this case right here, the loop is going to go 1 extra time. So here's an example. In this case, we have testing and then adding. So now we can see here that this loop is actually going to go 5 times, because before the loop count is 0, and then it's going to test 0 less than 5 and then increment. So this loop is actually going to run 5 times when you do count plus plus. When you do plus plus count, the loop is actually only going to go 4 times. So you have to be very careful when you increment and decrement, and when you're using plus plus count or count plus plus. So the ternary operator, this can be used. Here's an example. You can say, this says if 1 is greater than 2, then n is going to, the n is right here. This is an assignment statement, so you're going to assign a value to n. If 1 is greater than 2, then you're going to assign the value 21 to n. And if 1 is not greater than 2, which happens to be the truth, then we're going to assign 42 to n. So here we have, if n and e and m are equal, then you are going to take m and assign it the value 21. Otherwise, you're going to assign it 21 to n. So you can use this, it's fine, but you could also use conditions if else. This is just a shorthand way to do this. So here's how we use if. I always like to tell students you are not required to have an else, you can just have an if. You assume that hours has a value, you assume that rate has a value, etc. This is just an example. This would have to be inside of like a main function. In C++, you can't have just conditions just sitting there. They all have to be nested inside of either the main function or a programmer defined function, but it can't just be, this is just overview of what this looks like. So keep that in mind, it must be inside of a function. So if hours is greater than 40, then you're going to go inside of here. If hours is not greater than 40, you're just going to continue on with your program. You can use an if with a matching else. So if hours is greater than 40, you go in here. And if it's not, you go here. Now you might notice that the if has curly braces to indicate a block of code, and the else does not. If you're only doing one statement, you don't need curly braces, but I recommend, just for readability, to put the curly braces. It makes it very clear what belongs in which block of code. Here is an example of a while loop. Now in this case, we do need curly braces because we're doing two things inside of our block. So since we're doing two things inside of our block, we need to have curly braces. When you have a loop, it's very important that you initialize, you test, and you update. Um, there's for loops, while loops, and do while loops, and the structure are very different for all of them. The most versatile loop is a while loop. So in this case, we're just going to do a countdown, and we're going to uh, start at a number. The user is going to give us how many times the loop. So if the user gives us a 5, the loop is going to run 5 times. If the user gives us a 4, etc. All right, so this is an example of a do while loop. Do while loops a lot of times are used for user validation. So the thing about a do while loop is that a do while loop is going to do it before it tests, where a while loop is going to test first. So there's a chance that that something could be false and you may never go inside of the while loop body. Whereas a do while, you're always going to do whatever is inside of this loop body. You're going to do it one time no matter what. And we're going to do in more detail loops in the next module. All right, let's talk just a little bit now about programming style in C++. C++, you use meaningful variable names. So it's unlike Python where names are all X, R, Y. You know, in C++, it's very standard to use names that identify things. There are identifiers, so it's very clear when looking at your code what those identifiers are standing for. Indentation, although it is not required like it is in Python, it is useful to make code easier to read. So there should be, everything is grouped in curly braces, and so inside of a block of code that starts with a curly brace. So if you have a block of code, say with your header up here, your curly, so just say it's an if condition, whatever, everything should be indented here that belongs in that. And then if you have a nested one, you would have everything here would be indented like that. So there's a style to it, and I use the same style in all of my examples. And you even have the assignment 0, which has a lot of code, for a beginning class. Enough code that you could take a look at it and look at the style and the indentation. So that's what I said. Style should be easy to read. You should put comments throughout your code in key locations, and you should get in the habit of commenting your code. Really, when you're starting out, it's nothing wrong with having extra comments in your code. That helps you to understand what's going on. It helps whoever's grading your code to understand what you mean as well. All right. You should always have a descriptive header comment at the top of your code that includes your name, date, and a brief description. And a brief description is not assignment 4 or learning about functions. A brief description describes what the program actually does, like manages a list of vegetables. Like it's not, I know that it's a class, but you should also describe what the program does in your header comment. There is some situations where things your compiler or IDE may behave in an unexpected way, and you should work hard to identify problems and have that, and try to fix them. Try to look at the warnings you're getting back and try to identify problems, and you should not program with the expectation that there's going to be any undefined behavior. In addition, different compilers handle undefined behavior in different ways. So, there are rules. Some compilers will automatically assign values to variables, but that's not a standard in the language. You need to, some compilers will allow you to mix data types. That's also not a standard. You need to be aware of your data types. You need to allocate your memory. You need to cache your data types if you are assigning things. You should be in control and try to well define your code so that you do not end up with undefined behavior. Thank you.